Okay, good morning Year 6 and welcome to our second lesson on algebra. And today we're going to be exploring two-step function machines. Okay, we're going to start with our flashback work first. So have a read of these questions and then press the pause button and have a go at them. Okay, question 1. What might the rule be for this function machine? 50, a function, equal output is 100. Okay, well what could it be? So it could obviously be add 50, or alternatively it could be multiplied by 2. Okay, number 2. What is 10% of 300? Well, I know that 10% is the same as 1/10, and I find 1/10 of something by dividing it by 10. So to find 10% of 300, I'm just going to divide it by 10. 300 divided by 10, we move the digits one place to the right, get the answer of 30. Number 3. Divide 26 by 100. Well, to divide any number by 100, we move the digits, each digit, 2 places to the right. So my 2 tens on my 20 is going to become 2 tenths, and my 6 ones is going to become 6 hundredths. So 26 divided by 100 is going to be 0.26. Number 4. How many metres are there in 5.5 kilometres? Well, I know that kilo means 1,000, and I know that there are 1,000 metres in a kilometre. So in 5.5 kilometres, there's going to be 5,500, which is the same as 5,500 metres. Okay, well done if you got all of those right. Okay, moving on to today's learning focus. I can explore two-step function machines. Okay, so yesterday we looked at one-step function machines. We had an input. There was a function that acted on that input to give us our output. Today we've just got one more step in that. So we have our input, we have our first function, and then we have kind of a midpoint output. We then, at that midpoint, need to act another function on that number to get the final output. So in this case, we have 3 multiplied by 2 is the first function. We have that midpoint of 6. We then act the second function on it, which was add 10, to get the final output of 16. Okay, this is the two-step function machine example. And we perform 2 operations on the input. Okay, for each number you put into a two-step function machine, there is an output, just like there was in the one-step examples. Now, do you think a function machine such as +5 and then +6 is a two-step function machine? Or do you think it could be written as a one-step function? Have a little think about that and pause the video. Okay, well, hopefully you recognise that adding 5 and adding 6 is exactly the same as adding 11. So in that case, that wouldn't actually be known as a two-step function machine. We would put those together and just add 11. We will look at different strategies we can use to find the functions when we're only given the output or the input today, and we will also use trial and improvement and consider the pattern of differences to arrive at an answer. Okay, on to the first question. So here is a function machine. The input number is then multiplied by 2. We then add 5 to the answer from the first step before we get the final output. Okay, read through these 3 questions and pause the video to work them out. Okay, the first one. What is the output if the input is 5? Well, I'm going to input 5, multiply it by 2. My midpoint answer is going to be 10 then. I then add the second function on my number 10, which gives me an output of 15. Second question. What is the input if the output is 19? Okay, this time reading the question really carefully, we have to notice that this time we're starting with the output, so we're going to have to work backwards. In order to work backwards, we're going to have to do the inverse function that's given in the function machine. So we're going to start with our 19, and instead of adding 5 to 19, we're going to do the inverse. So we're going to subtract 5. That's going to give us a resultant answer of 14. That's kind of our midpoint number working backwards. We then have our 14. We then need to act the first function on it, but the inverse of the first function. So the inverse of times 2 is going to be divided by 2. So we divide 14 by 2 to get an input number of 7. Okay, and the last one, okay, with a decimal number. So this time the input number is 3.5. 3.5 times by 2 is 7. That's our midpoint number. We're then going to act the second function on our 7 to get an answer of 12. Okay, well done if you've got those right. Okay, our second question. Complete the table for the given function machine. This time it's times 3 and subtract 4. You've got to put them into the table, and then you've got to work out patterns that you notice in the output. So once you've worked them out, have a look at each of those numbers and see if you can see a pattern occurring and prove the pattern. And the final part of that question, what is the input if 20 is the output? So again, you're going to have to work backwards once you've worked out what it could be. Okay, pause the video and have a go at these for me, please. Okay, if the input is 1, the output is going to be -1. Because 1 times 3 is 3, subtract 4 is -1. If the input is 2, so 2 times 3 is 6, subtract 4 is 2, so the output's going to be 2. What about if the input is 3? Well, 3 times 3 is 9, 9 subtract 4 is 5. 4 multiplied by 3 is 12, 12 subtract 4 is going to be 8. And finally, 5 times 3 is 15, 15 subtract 4 is 11. Okay, so I'm going to have a look at those answers, see if I can work out a pattern. So going from -1 to 2, I'm going up in 3. Oh, okay, let's have a look. Going from 2 to 5, I'm also going up in 3. I think the rule might be add 3. Let's just check it out. 5 plus 3 makes 8. Yes, it does. 8 plus 11. 8 plus 3 makes 11. Yes, it does. So I'm confident that the rule is add 3. It was going up in 3s each time. Okay, what is the input if 20 is the output? Okay, just like we did in the last question, we're going to have to work backwards through our function machine using the inverse operation. So I'm going to start with my output of 20. I'm going to do the inverse of subtract 4. I'm going to add 4, give me my midpoint number of 24. I'm then going to add the inverse of the first function, which is going to be divide by 3. So I've got 24 divided by 3, which gives me an input of 8. Okay, well done if you got that right. Moving on. Okay, so how could you write this two-step function machine as a one-step machine? Okay, please check by inputting values. Okay, pause the video, please. Okay, let's have a look. So, plus 3 and then plus 5 is the same as adding 8. Okay, I think the function machine could be 8, but I'm just going to check it by inputting values. So I'm going to put 2 into it. 2 plus 3 is 5. 5 plus 5 is 10. Okay, let's just check that my single function machine is the same. I'm going to input 2. 2 plus 8 makes 10. Yes, I'm confident I've got the right answer because I've checked it. Okay, next question. Teddy has 2 function machines. The first